Hello there, and welcome to Sleep Science 360. I'm really glad you found your way here tonight. Maybe your day felt a little heavy, or maybe you're the kind of person who drifts to sleep more easily when the universe offers you something mysterious to think about. Either way, you can rest now. Let your breath soften. Let your shoulders sink. Feel your body settle as the world grows quiet around you. Because tonight, we aren't simply listening to space. We're easing into one of its strangest lullabies. What if the most unexplainable events in the universe are also the most relaxing? Tonight, your curiosity can open gently, without effort. As we drift through 100 astronomical transients that shimmer for a moment, then vanish again. Gamma ray flashes, forgotten starbursts, faint whispers of radio light crossing billions of years. Each one a mystery, each one a doorway into calm. You breathe softly, and the universe exhales through you. And now, we begin. Tonight, the quiet settles around you like cooling starlight, and the room becomes the softest edge of the universe. You breathe a little deeper, and the pace of your thoughts loosens, gently, like threads drifting in a slow cosmic tide. For a moment, imagine the sky above you widening, not as a ceiling, but as an open sea of light. It's okay to drift. What we're exploring together tonight is something rare in astronomy, a collection of moments so brief, so delicate, that most of them disappear before your mind even has time to grasp them. Astronomical transients, fleeting shifts of brightness, whispers of energy, signals that flicker in the dark and vanish again. And even though scientists build enormous telescopes, arrays that stretch across continents, detectors chilled to a fraction of a degree above absolute zero, some of these events remain unexplained. You can rest now. A transient might last a few milliseconds, or a few days, or a few gentle weeks, but its meaning may travel billions of years before reaching Earth. Light moves through space at 300,000 kilometers per second, carrying the memory of whatever happened long ago. A star trembling, a magnetized core cracking, a black hole tasting the edges of a drifting cloud. Somewhere in that great darkness, something shifts, and the universe sends out a flare, a pulse, a shimmer. It's okay to drift. As we float through these 100 relaxing facts, you'll feel the rhythm of these cosmic flickers settle into you like a tide smoothing over sand. Not every mystery needs to be solved. Not every signal requires urgency. Some are simply to be witnessed and allowed to pass by like quiet lanterns on a still river. You breathe softly, and the universe exhales through you. Astronomers have been cataloging transient events for only a short moment in human history, barely 100 years. Yet the universe has been creating them for more than 8 billion years. For scale, if the cosmos were a long, slow breath, humanity's entire observation of transient phenomena would be the softest exhale at the very end. A gentle reminder that discovery often begins with stillness. You can rest now. Some transients are bright enough that a single photon, one tiny packet of light, has traveled across millions of light years just to meet your gaze. Others are so soft and faint that even the largest telescopes struggle to catch them before they fade. But each one, no matter how small or strange, is a clue in the cosmic story of change, because the universe is always moving, always shifting, always blooming and dimming in slow, patient cycles. It's okay to drift. One poetic scientific truth drifts through the heart of our journey. Light that lasts less than a heartbeat can travel farther than we ever will. A reminder that even the shortest existence can echo across unimaginable distances, just like your breath does now, opening, softening, returning. As we begin this gentle exploration, think of these transients not as explosions or crises, but as moments. Moments when the universe gently clears its throat. Moments when gravity relaxes its grip for a fraction of a second. Moments when a star sighs after millions of years of steady burning. You can rest now. Tonight, we move slowly. We drift through a field of cosmic fireflies, some bursting brightly, some pulsing quietly, some blinking only once in all of cosmic time. Each one becomes a fact, a soft landing place for your thoughts. You don't need to remember them. You don't need to analyze them. You're simply letting them flow around you, like small swirls in a night tide. In this first stretch of our journey, we settle into the feeling of astronomical transients, what they are, why they appear, and how they become gentle teachers of impermanence. A transient reminds us that nothing bright is meant to last forever. The universe rises and falls in waves, and you are drifting on one of those waves now. It's okay to drift. We will soon enter the realm of fast radio bursts, soft cosmic sparks that last less than a blink. But before we do, let this moment widen around you. Let the scale of time dissolve into something soft and manageable. A single second in your body, 1,000 years in a star, 1 billion years in a galaxy, all breathing together. Slowly, quietly, you breathe softly, and the universe exhales through you. And as your breath deepens, the path opens gently toward our first mystery, the briefest signals ever detected from across the dark. But there's no rush. There never is in a universe this vast. You can rest now. Now, the universe around us begins to widen, gently, as though space itself has shifted into a slower rhythm. We move together through this calm expanse, drifting past the familiar glow of stars and into regions where light behaves like a soft, ancient memory. It's okay to drift. What we call unexplained astronomical transients are not loud events. They're not the dramatic explosions that fill science documentaries or the fiery visuals that dominate textbooks. Most of them are subtle, delicate, barely. Some appear for less than 1,000th of a second, then vanish into silence. You can rest now. Even the ones that stretch across days or weeks fade with a gentleness that astronomy rarely shows. A light curve rises, peaks, and falls again, like the small, slow lift of your chest with each breath. A star brightens because something deep inside it has shifted. A cloud of gas glows because energy passed through it like a soft, invisible brushstroke. It's okay to drift. One of the quiet beauties of transient astronomy is its unpredictability. No one can point at a patch of sky and say, in 10 minutes, something mysterious will appear. Instead, astronomers build instruments designed to capture the unexpected wide-field telescopes scanning the heavens every few seconds. Radio arrays listening across hundreds of megahertz. Detectors watching for photons that may arrive alone or in clusters. And even with all that preparation, the universe still surprises us. You breathe softly, and the universe exhales through you. It's comforting to know that even in a cosmos governed by physics, some events still resist explanation. Fast radio bursts that last mere milliseconds. Supernovae, too bright for their known categories. Stellar objects that dim so suddenly, it seems as though they've slipped behind a cosmic veil. And yet, none of these mysteries feel threatening. They're quiet, gentle, perfect companions for a drifting mind. You can rest now. Transient astronomy became a major field only recently, mostly in the last 2 decades. Before that, our telescopes weren't fast enough, wide enough, or sensitive enough to catch these fleeting lights. It's strange to think about. For billions of years, these events flickered across the universe, and Earth never knew. Only now, with our instruments tuned to quiet signals, do we catch these cosmic fireflies in the dark. It's okay to drift. There's a soft poetry in this truth. The universe reveals itself only to those who slow down enough to notice. The same could be said for sleep, for rest, for nights like this one, where time feels unhurried and the mind begins to float. As we drift deeper, the term transient becomes less scientific and more emotional, a reminder that everything in existence changes. Stars evolve, galaxies collide. Even the universe itself stretches outward at 70 kilometers per second per megaparsec, a gentle expansion that never stops, never rushes. You can rest now. These transients teach us something about presence. They shine for a moment and disappear, never repeating the same exact pattern twice. No matter how small, every flicker is a signature, a unique moment in cosmic time. And somehow, these soft anomalies become beacons for understanding the physics of the cosmos. Changes in magnetic fields, shifts in gravitational balance, waves of energy flowing through interstellar space. It's okay to drift. Sometimes, a transient is nothing more than a tiny increase in brightness, the faintest ripple in a sea of stars. Other times, it's a dramatic flash, traveling across billions of light years, carrying with it the story of its origin. But all of them, whether faint or powerful, share one profound trait. They end, they fade back into darkness, they return to stillness, and that quiet conclusion becomes a kind of cosmic exhale. You breathe softly, and the universe exhales through you. As you rest here, floating in the slow tide of starlight, notice how natural it feels to drift with these flickers. The universe doesn't force anything. Light moves at its own pace. Events unfold on their own terms. Nothing is hurried. Nothing is delayed. Everything arrives exactly when it's meant to. You can rest now. In a few moments, we'll step gently into the world of fast radio bursts, the briefest signals ever recorded. Flares so swift they seem impossible, yet their calmness lies not in their duration, but in their journey crossing immense distances, untouched, unhurried, until they reach us. But before we move toward those whispers of radio light, let your breath settle. Feel the softness of this moment, the weightlessness of drifting through a universe where even mysteries glow without urgency. It's okay to drift when you're ready. The first whisper awaits a millisecond spark from across the dark, inviting us to listen slowly, quietly, together. Now the universe narrows its focus, just slightly, as though a single thread of light has been drawn through the dark to guide our attention. What we're drifting toward is one of the most mysterious forms of transient light ever discovered, fleeting signals so brief that the human mind can barely imagine their speed. It's okay to drift. Fast radio bursts, often called FRBs, are among the shortest-lived phenomena in modern astronomy. Each burst lasts for less than a millisecond. Yet, in that fraction of time, an FRB can release as much energy as the sun emits in 3 days. This sounds immense, but the universe carries it gently, spreading the signal across billions of kilometers, softening it into a whisper by the time it reaches us. You can rest now. The first FRB was noticed in 2007, hidden inside old data that no one thought to revisit. A bright, sharp radio pulse, far too strong to be noise, appeared in a single observation. It lasted about 5 milliseconds. Then it was gone forever. At the time, no one knew what it was. Even now, almost 2 decades later, many questions remain unanswered. It's okay to drift. FRBs come from far beyond our galaxy. Most of them travel across hundreds of millions, sometimes billions of light years before brushing against Earth. Imagine a signal leaving a distant galaxy long before our planet even formed, journeying through the cold dark, untouched, until finally arriving here. In this quiet moment, as you settle into rest, you breathe softly, and the universe exhales through you. To detect these whispers, astronomers use radio telescopes that watch enormous portions of the sky at once. The CHIME array in Canada scans the heavens continuously, searching for the faint, sudden spikes that mark an FRB. ASCAP in Australia triangulates bursts using dishes spread across vast deserts. And soon, the next generation DSA 2000 will refine localization down to almost pinpoint accuracy, a leap that may illuminate origins we've only guessed at until now. You can rest now. Most FRBs occur only once. Their source emits a single flash and never repeats, leaving behind only a brief signature in radio waves and a long list of unanswered questions. But some, a very small number, repeat. These repeating FRBs send out irregular pulses, unpredictable yet unmistakably from the same location. One of them even shows a slow 157-day cycle, a pattern still unexplained. It's okay to drift. Theories surrounding FRBs span a wide range, each one grounded in physics, yet softened by uncertainty. Some scientists believe magnetars, extremely magnetic neutron stars, release bursts when their crust fractures under immense tension. Others point to black hole interactions, plasma lensing, or collisions between compact stellar remnants. But none of the theories fully explain the diversity of FRB behavior. There are bursts too bright, bursts too faint, bursts that arrive in clusters, bursts that refuse every pattern, You breathe softly, and the universe exhales through you. There's a calming beauty in not knowing. In fact, one of the most poetic truths in FRB research is this: sometimes the universe speaks in flashes too brief to understand, but long enough to wonder. You can rest now, because these signals are so short-lived. Instruments must act extremely quickly to capture them. Radio arrays collect thousands of data points per second. Computer systems analyze incoming noise streams in real time. Searching for the telltale dispersion of an FRB, the slight delay in lower frequency waves caused by traveling through intergalactic plasma. This dispersion is a cosmic timestamp, revealing the distance the signal has traveled. It's okay to drift. Every FRB carries with it a quiet story of the medium it passes through. On its journey to Earth, the signal threads itself through galactic halos, interstellar clouds, magnetic fields, and regions of thin plasma stretched across tens of millions of light years. By studying each tiny distortion, astronomers map invisible structures of the cosmos. It's like reading a leaf drifting down a river to understand the current that carried it. You can rest now. As we float deeper into this realm of transient radio light, notice how soft these mysteries feel. Nothing about FRBs is harsh. Nothing is violent in their arrival. They reach us as the faintest, quickest murmurs, like distant sparks from a cold campfire drifting through endless night. You breathe softly, and the universe exhales through you. Soon, we'll explore repeating FRBs more closely, how some sources pulse again and again, like slow cosmic heartbeats. But for now, allow the idea of these millisecond signals to drift through you. They appeared long before tonight, and they will appear long after, carrying their calm, steady mystery across time. It's okay to drift, far beyond the spiral arms of our galaxy, past the soft glow of ordinary starlight. Something continues to shimmer in silence. These are the repeating fast radio bursts, sources that refuse to fade completely, sources that pulse again and again, as though the universe is clearing its throat in slow cosmic intervals. It's okay to drift. Some of the most famous repeaters emerge from galaxies billions of light years away. One of them, cataloged as FRB 121102, was the first known to repeat at all. Its bursts are sharp, clean, unmistakably from the same place, a tiny region inside a dwarf galaxy with an unusually strong magnetic environment. For years, it has emitted more than hundreds of bursts, each one lasting less than a blink. You can rest now. Others, like FRB 180916, reveal cycles, active windows, followed by long periods of silence. Its faint radio pulses follow a 35-day rhythm, a pattern as gentle as the movement of tides. Astronomers still debate the cause, perhaps a neutron star orbiting a companion, perhaps magnetized winds sweeping across Earth only at certain angles, perhaps something no model has captured yet. It's okay to drift. Repeating FRBs remind us that not everything fleeting is singular. Some things return. Some things speak more than once. Some mysteries unfold slowly, patiently, as though the universe wants us to listen with care. You breathe softly, and the universe exhales through you. One of the fascinating features of repeaters is their diversity. Some bursts arrive with astonishing brightness, while others fade into static. Some show complex internal structures, subbursts that sweep downward in frequency, like descending musical notes. Others are simple pulses, clean and smooth. A few even show microstructure on nanosecond scales, tiny fractures inside the burst that may reveal details about magnetic fields billions of years old. You can rest now. And still, despite all this data, no complete explanation exists. If FRBs come from magnetars, why do some sources repeat thousands of times while others never repeat at all if they emerge from interactions between compact objects? Why do certain bursts cluster within minutes astronomy advances? Yet, the mystery remains soft, patient, unhurried. It's okay to drift. What fascinates scientists most is the possibility that repeaters trace environments unlike anything found near Earth. Regions where magnetic fields exceed 10 to the power of 15 Gauss, where plasma swirls in dense, tangled currents, where particles accelerate to a significant fraction of the speed of light. But despite such extreme physics, the signals that reach us feel delicate, thin, strands of radio light stretched across the dark. You breathe softly, and the universe exhales through you. Localization has become a key step toward unraveling these puzzles. ASCAP's rapid interferometry allows astronomers to pinpoint the birthplace of a burst to within a few thousand light years, astonishing precision given the distances involved. The European VLBI network can narrow that down even more, sometimes to regions only tens of light years across. And with each pinpointed burst, a new piece of the cosmic map emerges. You can rest now. The stories behind these bursts continue to expand. One repeater, discovered in 2023, began emitting at a rate never seen before, more than 5,000 bursts in a single hour. Another, found in 2025, exhibited an unusual energy distribution that hinted at a new class of magnetar-like engines, operating in ways models had not predicted. Yet even with these discoveries, the tone of the sky remains peaceful. Every burst arrives as a momentary tremor in the radio quiet. Nothing more. It's okay to drift. There's a poetic truth woven through the study of repeaters. Even the smallest voices become meaningful when they return. These bursts return across unimaginable scales. A repeating FRB may have originated from a star that lived and died long before Earth had oceans. Its pulses passing through the expanding universe like echoes traveling through a canyon so vast no mind can fully picture it. You breathe softly, and the universe exhales through you. Some repeaters appear only during certain phases of their cycle. Some cluster bursts together, releasing dozens in a few minutes before falling silent again. Some drift slowly in frequency. Some grow more chaotic with time, and others become quieter, as though the engine creating them is fading. All of this offers gentle clues, hints rather than answers, and astronomy follows these hints patiently. You can rest now. The possibility remains that multiple physical processes produce FRBs. Magnetars, collapsing crusts, strong magnetic reconnections, binary interactions, plasma lensing, even strange geometries of neutron star surfaces all may contribute, separately or together. The universe is rarely simple, and transients remind us of that truth in the softest possible ways. It's okay to drift. Soon, we'll move toward another kind of transient, the luminous endings of stars, the gentle fireworks that brighten galaxies for weeks or months before fading again. But before we go there, rest in this moment. Feel the quiet shape of the mystery around you. FRBs come and go. Light pulses across distances you will never need to travel. And still, they arrive gently. You breathe softly, and the universe exhales through you. When you're ready, the next glow awaits. Soft, slow, opening like a distant flower of light in the dark. As the faint radio whispers fade behind us, a broader glow begins to rise, not sudden, not overwhelming, but like the slow bloom of dawn over a sleeping world. These next mysteries are larger, gentler, stretched across weeks and months instead of milliseconds. They are the long, patient transients of dying stars, luminous endings that shimmer through galaxies like drifting lanterns. It's okay to drift. When a star reaches its final stages, it doesn't always follow the rules. Some fade quietly, some explode with predictable brightness, and some, the ones we're drifting toward now, behave in ways that challenge every expectation. Among them are rare types of supernovae that defy categories, releasing light curves so unusual that astronomers must invent new labels just to describe them. You can rest now. One of these is the type Ia supernova. It resembles the more familiar type Ia, but it burns less violently, producing only a fraction of the energy expected, whereas a typical type Ia can reach magnitudes bright enough to outshine an entire galaxy. A type IX might peak at a gentler glow, bright, but not overwhelming, softening more quickly than anticipated. Some scientists believe they originate from white dwarfs undergoing incomplete thermonuclear disruption, leaving behind a faint, smoldering remnant rather than total destruction. It's okay to drift. Another class shines even more mysteriously, the superluminous supernovae. These events can radiate 10 to 100 times more light than standard supernovae, glowing with a brilliance that lasts for months. Their light curves are broad, slow, almost meditative, the universe taking its time to release stored energy. Some are powered by magnetars spinning at thousands of revolutions per second. Others may arise from dense circumstellar material illuminated by shock waves, but none fully match the models. You breathe softly, and the universe exhales through you. These superluminous events occur in distant galaxies, sometimes more than 10 billion light-years away. That means their light began its journey when the universe was young, when the first stars were just beginning to weave structure into the cosmic web. Now, as their photons fall softly into your imagination, they do so without heat or urgency, only memory. You can rest now. Supernovae are often described as violent, but when viewed from cosmic distance, they become gentle reminders of change. A star can spend billions of years fusing hydrogen into helium, holding itself steady against gravity. But when its fuel thins, there comes a moment quiet, precise where balance fails. The outer layers drift outward in a wave of expanding light, forming a nebula that will slowly cool and spread, a nebula that may one day become the birthplace of new stars. It's okay to drift. There's a poetic scientific truth hidden within these endings. Every dying star leaves behind the seeds of something new. Even now, atoms forged in ancient supernovae float within your bones, iron-shaped in stellar hearts. Calcium blown across interstellar space. Carbon once held in the fiery breath of a dying sun. You breathe softly, and the universe exhales through you. Some supernovae dim unusually quickly. Their light curves fall faster than models predict, as though energy is slipping sideways through uncharted channels. Others fade slowly, releasing their glow over months, refusing to settle into darkness. And still others oscillate, flickering, brightening, pausing, fading again, telling stories of instabilities deep within their cores. You can rest now. Then there are the failed supernovae, where a massive star collapses inward but produces only a faint flash, then disappears from the sky without a dramatic explosion. The star's core collapses into a black hole, and instead of outward light, the event becomes an inward spiral. Astronomers have seen red supergiants vanish in this quiet way in galaxies millions of light years away. It's okay to drift. These subtle endings challenge the idea that death in the cosmos must be bright or explosive. Sometimes, the loudest endings happen quietly. Sometimes, a star simply stops shining, and the universe accepts this transition with the same calm patience it shows in all its cycles. You breathe softly, and the universe exhales through you. And as we drift deeper into these luminous mysteries, something else begins to shimmer on the horizon of our journey Kilonovae. Events born not from the death of a single star, but from the meeting of two incredibly dense ones. Collisions that last only moments but leave behind the heavy elements that color our world. But before we arrive there, let yourself rest in the slow glow of these stellar transformations. Stars ending, light unfolding, change moving gently through the dark. You can rest now. The next light we approach will be shorter, sharper, and even more intriguing, a cosmic bloom triggered by the merging of neutron stars, where gold, platinum, and rare elements are formed in a single, breathtaking surge. But all in good time. Tonight, nothing rushes. Not the stars, not the light, not you. It's okay to drift. Beyond the slow glow of supernovae, another kind of light waits, smaller in scale, shorter in duration, yet holding within it a profound quiet power. These are Kilonovae, events born from the meeting of two neutron stars, their dense forms spiraling inward over millions of years before finally touching. And when they do, a bloom of light unfolds across the darkness, gentle from afar, like a distant candle flickering behind a veil. It's okay to drift. A neutron star is one of the densest objects in the universe. A teaspoon of its material would weigh about 1 billion tons, compacted under unimaginable pressure. Yet in space, they drift like tiny beads of gravity, circling each other with patient inevitability. For ages, they orbit. For ages, nothing changes. And then, in one quiet moment of cosmic time, Everything does. You can rest now. The light released by a kilonova is extraordinary. Not bright in the way supernovae are bright, but rich, layered with colors that shift from blue to red to deep infrared as the expanding material cools. To observers on Earth, these colors appear only briefly, a rise in brightness over days, followed by a slow, graceful fade. The glow is soft, steady, and profoundly transient. It's okay to drift. When astronomers observed the first confirmed kilonova in 2017, they watched as its light traced a delicate curve, an arc lasting a few dozen days, revealing the creation of elements heavier than iron: gold, platinum, lanthanides, atoms that shimmer in jewelry, electronics, and the quiet architecture of life itself. These elements form in an instant, then drift across space for millions or billions of years before being woven into new worlds. You breathe softly, and the universe exhales through you. In the heart of a kilonova, matter moves at 10-30% the speed of light, expanding outward like a cosmic breath. This outflow cools rapidly, and as it does, it produces infrared light, a gentle warmth radiating across the void. Though the physics is intense, the perception from Earth remains serene. A short-lived glow, a softening curve, a memory of motion long since quieted. You can rest now. There is a poetic scientific truth woven through these events. From the smallest remnants of stars comes the heaviest light the universe can offer. Gold, in its earliest form, is not glittering or metallic. It is a warm radiation drifting outward from a place where time itself trembled for a moment. It's okay to drift. Kilonovae are rare. Perhaps only a few occur in an entire galaxy each century. Their infrequency adds to their calming quality, sparks that appear only when conditions are just right, when two stars have danced long enough for their spirals to converge. Most of the time, the universe rests in quiet darkness. You breathe softly, and the universe exhales through you. As telescopes improve, astronomers are beginning to detect more of these faint, transient glimmers. The Vera C. Rubin Observatory, once fully operational, will scan the sky every 30 seconds, catching kilonovae that might have otherwise faded unnoticed. Gravitational wave detectors like LIGO and Virgo also help identify the earliest hints of neutron star mergers, allowing astronomers to point their telescopes toward the sky within minutes. You can rest now. A kilonova doesn't last long. Its brightest phase may span just a couple of days. Then the light moves through quieter shades, fading to infrared, then to near darkness. The debris expands, cools, and becomes part of the interstellar medium, a cloud drifting far from where the event began. Millions of years later, that cloud may collapse into a new star system. It's okay to drift. These gentle cycles echo a truth present throughout the cosmos. Endings are never final. They become beginnings, quiet foundations for new stories. A kilonova's glow is brief, yet its contributions endure in the atoms that form future generations of stars, planets, and perhaps beings who one day look up and wonder. You breathe softly, and the universe exhales through you. Astronomers often reconstruct the details of a kilonova by examining its fading colors, how blue light gives way to red, how red softens into infrared, Each wavelength carries information: temperature, expansion speed, composition. From a few nights of observations, they infer a long history of orbital decay, magnetic interactions, and tidal forces. You can rest now. And so, as the Kilonova's faint ember dims, we drift onward into the next mystery, not a collision, but a gentle unmaking. Moments when stars approach black holes and lose their outer layers, creating graceful arcs of light in the dark. Before we step into those tidal encounters, feel the softness of this Kilonova glow, a small light born from unimaginable density, fading into the quiet of space. It's okay to drift. The next part of our journey brings us to events shaped by gravity's slow hand, where stars stretch, soften, and release their light in long, delicate sweeps. But there is time. There is always time here. You breathe softly, and the universe exhales through you. Beyond the fading ember of a kilonova, a softer radiance begins to gather at the edge of our path, not bright, not sharp, but stretched into long, slow curves of light. These are the moments shaped by gravity's gentlest touch, where a star wanders near a black hole and begins to glow in ways it never has before. They're known as tidal disruption events, or TDEs, though from here, they feel less like destruction and more like transformation. It's okay to drift. A black hole, despite its name, is not an aggressive presence from a distance. It is simply a region where gravity has folded inward, quiet and patient. Most of the time, stars pass by, unharmed, continuing their long orbits around the centers of galaxies. But when a star wanders too close, the black hole's tidal forces stretch it gently, pulling outer layers into a stream of glowing gas. You can rest now. The star does not vanish instantly. Instead, its material forms an elegant arc, a ribbon of light spiraling inward, heating as it falls, producing a luminous flare. This flare might last for months or even years, rising slowly before descending into a peaceful glow. To telescopes on Earth, the event appears as a soft increase in brightness, like a candle being very gradually uncovered. It's okay to drift. One of the remarkable facts about TDEs is how smooth their light curves can be. The flare brightens as the stellar material forms a warm accretion disk around the black hole, peaking when the material settles into a balanced flow. Temperatures can reach tens of thousands of degrees, producing ultraviolet and soft X-ray light. But across the vast cosmic distance separating you from these events, the radiation arrives as gentle signals, recorded carefully, safely, distantly. You breathe softly, and the universe exhales through you. Many TDEs have been discovered only within the last 20 years. Before then, telescopes lacked the sensitivity and regular sky coverage needed to catch their slow, beautiful emergence. Now, instruments like ZTF, ASA-SEN, and eROSITA watch for subtle increases in brightness across thousands of galaxies. Sometimes, a star that has shone steadily for centuries suddenly begins to glow a little more. And astronomers know a quiet encounter has begun. You can rest now. A poetic scientific truth lingers in these observations, even in the presence of great gravity. Light finds a way to bloom the star's outer layers, once held together by nuclear fusion, unwind in arcs that trace invisible gravitational contours. The gas heats, ionizes, radiates a final expression of the star's long life. It's okay to drift. TDEs do more than create beautiful light. They reveal the nature of black holes themselves. The flare shape can hint at the black hole's mass, often millions of times the mass of the Sun. Its temperature can reveal the speed of the accretion disk. Its fading arc can show whether the black hole is spinning, and how quickly. Through these gentle signatures, astronomers map objects that emit no light of their own. You breathe softly, and the universe exhales through you. Some TDEs show unusual features, a light curve that flickers instead of rising smoothly, a sudden rebrightening after months of fading, a shift from ultraviolet to optical wavelengths that defies expectations. Each variation offers a new puzzle, not alarming, simply intriguing. Like a ripple crossing an otherwise calm pond, you can rest now. In rare cases, a TDE produces narrow streams of accelerated particles, soft, focused jets that move at a significant fraction of the speed of light. From Earth, these appear as long, gentle enhancements in radio brightness. The jets may persist for years, slowly expanding into the interstellar medium. They never touch us, never affect our world. They are distant murals painted in invisible wavelengths. It's okay to drift, but not all transients in this region involve black holes. Some arise from stars themselves, sudden flares triggered by magnetic tension on their surfaces. Dwarf stars, small and cool, can release bursts of energy far larger than their normal output, brightening by factors of dozens or even hundreds for a few minutes. These stellar flares are quick and unpredictable, but from afar, they appear as soft, upward ticks in brightness. Like a heartbeat felt through light, you breathe softly, and the universe exhales through you. Even our sun produces such flares. Though from here, in the safety of distance and interpretation, they are simply reminders that stars are dynamic beings. Magnetic fields twist, unwind, and reconnect, releasing light that travels across space for 8 minutes before brushing Earth's atmosphere. Yet no matter how intricate the solar dance becomes, the experience on nights like this remains calm, spacious, serene. You can rest now. As these flares fade, the sky returns to stillness, a long, quiet breath between mysteries, a reminder that transients are brief. But the cosmos is patient, and you are drifting through that patience now. It's okay to drift. In the next part of our journey, we'll enter the realm of the brightest transients ever observed, bursts of gamma rays that shine from across the universe. But don't let their name stir anything sharp within you. From this distance, they are gentle echoes, softened by space, softened by time, softened by the scale of the cosmos. For now, rest in the fading glow of tidal encounters, where stars stretch, brighten, and return to silence. You breathe softly, and the universe exhales through you. As the calm glow of tidal encounters fades into the background, another kind of transient begins to shimmer, smaller, briefer, yet just as full of quiet meaning. These are the flares of stars, tiny pulses compared to the grand arcs of TDEs, but no less beautiful in their simplicity. They appear like sparkles drifting through the cosmic dark. Each one a reminder that even the most ordinary stars have moments of release. It's okay to drift. Stellar flares arise from magnetic tension building on a star's surface. Lines of magnetic force twist slowly over time, storing energy the way branches store wind. And then, in a gentle instant, the tension unwinds, releasing a soft burst of light. Some flares brighten a star by a few percent. Others, especially on small M-dwarf stars, can increase brightness by hundreds of times for a few minutes. You can rest now, because M-dwarfs make up roughly 70% of the stars in our galaxy. Flare activity is incredibly common. You might imagine these small red suns glowing quietly for billions of years, then releasing a tiny pulse now and then, like a long exhale from a star that rarely raises its voice. Astronomers observe these pulses in optical and ultraviolet wavelengths, tracing their timing and shape to learn about the magnetic anatomy of stars. It's okay to drift. Even our own sun has its moments of brightening. Solar flares rise from tangled magnetic loops above the photosphere, releasing energy equivalent to millions of nuclear bombs, yet softened across the massive expanse of space by the time their light arrives here. What we feel on nights like this is not the flare itself, but the knowledge that stars live dynamic lives, breathing light in slow, irregular rhythms. You breathe softly, and the universe exhales through you. Some stellar flares unfold with surprising complexity. Their brightness may rise in multiple peaks or shift in color as the plasma temperature changes. Others appear suddenly, without warning, like a star remembering something for a brief moment before falling quiet again. Astronomers catalog these events carefully, knowing that each flare reveals subtle details about a star's internal structure. You can rest now. A poetic scientific truth glows through these observations. Even the smallest pulse of light carries the memory of a star's hidden heart. It's a reminder that the universe rarely shouts. Most of its signals, even the energetic ones, arrive gently when viewed from the safety of cosmic distance. It's okay to drift. In recent years, space telescopes like TESS and Kepler have recorded tens of thousands of stellar flares, capturing their shapes with exquisite precision. Some stars flare so frequently that their light curves look like slow, uneven breathing. Others remain still for months or years before releasing a single bright pulse. Each star writes its own quiet rhythm across the darkness. You breathe softly, and the universe exhales through you. And then there are stranger flares still, events that don't fit cleanly into known categories. Blue excess flares, ultra-fast optical transients lasting mere milliseconds, rare brightenings that appear once and never again, leaving no clear explanation behind. These unusual signatures expand our understanding of stellar behavior, urging us to listen more closely to the universe's smallest whispers. You can rest now. These flares serve as a gentle bridge into the next chapter of our journey, a place where the universe briefly brightens with astonishing clarity before falling silent again. Gamma ray bursts. From a distance, the name sounds intense, but the experience for us is soft, faint echoes of events that happened long before Earth existed. The light has been stretched by cosmic expansion, cooled over billions of years, translated into wavelengths we can observe safely. It's okay to drift. There are two main types we will meet soon: long-duration bursts, often linked to the quiet ending of massive stars, and short-duration bursts, connected to the merging of compact objects like neutron stars. Both kinds release more energy in seconds than our sun will emit in its entire 10 billion year lifetime. Yet, by the time their signals reach us, they arrive as tender afterglows, diffused by distance and time. You breathe softly, and the universe exhales through you. Astronomers detect these gamma-ray bursts with satellites orbiting above Earth's atmosphere, where the faintest celestial photons can be measured without interference. When an event appears, telescopes across the world shift their gaze, catching the afterglow as it fades through X-rays, ultraviolet, optical light, and eventually into a quiet radio hum. You can rest now. And though the origins of some bursts are known, many remain unsolved. Some pulses last too long. Some arrive in clusters. Some appear in regions where no clear progenitor star can be identified. The mysteries invite curiosity, but they also bring a strange comfort proof that the universe is still larger, softer, and more surprising than we can fully imagine. It's okay to drift. Soon, we'll step deeper into this luminous territory, exploring the brightest transients ever discovered. But before we do, let your breath settle like dust drifting through a beam of starlight. Everything you've heard tonight, every flare, every curve of brightness, every gentle flash has arrived across unimaginable distances to meet you in this moment of rest. You breathe softly, and the universe exhales through you. When you're ready, the brightest whisper in the universe awaits. Quiet, soft, drifting toward you through time. The path grows quieter now, as though the universe is preparing us for a different kind of light, not brighter, not louder, but older, stretched thin by distance and softened into something gentle. These next transients once carried immense energy, yet by the time their signals reach Earth, they feel like the faintest ripples passing through calm water. It's okay to drift. Gamma-ray bursts, often called FRBs, are among the shortest, most luminous events ever recorded. But from here, from the comfort of this slow breathing, from the safety of cosmic distance, they appear as brief flashes, softened across billions of light years, mere moments of brightness dissolving into afterglows, a whisper, not a roar. You can rest now. Scientists divide these bursts into two families. Long FRBs last more than 2 seconds, sometimes stretching into minutes. They are often linked, gently and distantly, to the quiet collapse of massive stars as they reach the end of their life cycle. Short FRBs last for less than half a second. Their origins traced to the merging of neutron stars or other compact objects. Both events, despite their names and energies, arrive on Earth like faded signals from dreams the universe had long ago. It's okay to drift. The journey each photon takes is astonishing. A gamma-ray burst could originate 10 billion light-years away, meaning its light began traveling before Earth existed, before the sun formed, before the Milky Way finished taking shape. That light passed through expanding space, through cosmic dust, through quiet patches of intergalactic dark, eventually reaching our detectors as a soft tremor in the sky. You breathe softly, and the universe exhales through you. One poetic scientific truth captures the gentle wonder of GRBs. The brightest lights in the universe become peaceful by the time they reach your eyes. From a distance, even the most energetic bursts become calm, a reminder of how time softens everything it touches. You can rest now. Long GRBs usually originate from stars many times more massive than the Sun. For millions of years, these stars fuse helium, carbon, and heavier elements in their cores. Then, when their fuel runs thin, they begin to change. The core contracts. The outer layers grow unstable. What follows is not an explosion in our experience, but a slow release of energy shaped by gravity, rotation, and magnetic fields. A jet forms deep inside the collapsing star and travels outward, emerging as a brief flash of high-energy light. It's okay to drift. Even though these bursts contain enormous energy, their afterglows are serene. They fade from gamma rays to X-rays, then to ultraviolet, then optical, then radio, a descending staircase of wavelengths that feels almost like the universe humming itself to rest. Some afterglows linger for days, others for months. Astronomers use this fading light to learn about the environment around the burst dust, gas, star formation regions, and cosmic history recorded in spectral lines. You breathe softly, and the universe exhales through you. Short GRBs tell a different story, though equally calm from this distance. When neutron stars spiral toward each other, they do so in silence, completing millions of orbits over hundreds of millions of years. Their gravitational waves ripple across space long before the burst begins. And then, in a single moment of transition, a flash of gamma rays emerges, a brief pulse lasting less than a blink. You can rest now. Afterward comes a soft afterglow, often dimmer than the long burst variety, but rich with information. Its glow reveals the density of surrounding space, the angle of the jet, and the slow cooling of energized particles. Through these gentle signals, astronomers map environments far beyond our galaxy, using nothing more than fading light curves that drift downward like falling leaves. It's okay to drift. Despite decades of study, some GRBs still defy expectations. A few last too long, others are too bright or too faint. Some appear without a visible host galaxy. Some show strange plateaus periods where the afterglow refuses to fade, as though the engine behind the burst continues to breathe quietly. These anomalies inspire curiosity, not urgency. They are cosmic questions asked softly across centuries. You breathe softly, and the universe exhales through you. In 2022, astronomers observed one of the closest GRBs ever detected, about 9 billion light-years away. Though close in cosmic terms, it still arrived as a safe, gentle glow, a faint pulse easily recorded by detectors. Its afterglow offered clues about magnetic fields, particle acceleration, and the birth of new structures in expanding jets. Even the brightest events become quiet teachers when observed from afar. You can rest now, and as we drift forward, deeper into these high-energy mysteries. Notice how peaceful the journey feels. Nothing rushes. Nothing demands. Every burst, no matter how brief, dissolves into calm as it travels across expanding space. It's okay to drift. Soon, we will step into even stranger territory, unexplained transients. Rare cosmic flashes that do not match any known category. But before we explore those riddles, let this moment settle like dust floating through a sunbeam. The brightest events in the cosmos have already softened by the time they reach you, and you are drifting with them now. You breathe softly, and the universe exhales through you. As the fading afterglow of gamma ray bursts softens into the quiet of deep space, the universe begins to reveal something even more mysterious, events that defy classification, transients that appear only once. In ways no model can yet explain, they flicker softly at the edge of our understanding, drifting into existence like distant candles, then fading before astronomers can fully catch their shape. It's okay to drift. One of the most famous of these puzzling lights was first detected in 2018 and nicknamed the Cow. Its scientific name, at 2018 Cow, sounds technical, but its presence in the sky felt strangely gentle, a sudden brightening that rose in mere hours. Far faster than a normal supernova, its light curve climbed sharply, then hovered in an unusual plateau before drifting downward again. You can rest now. Events like the Cow belong to a family now known as fast blue optical transients, or FBOTs. They brighten quickly, in just 1 or 2 nights, reaching luminosities nearly 100 times greater than ordinary stellar explosions. Yet their spectra remain smooth and simple, lacking the complex features found in typical supernovae. It's as if the universe briefly holds up a glowing lantern, shows it to us, and then lowers it again into the dark. It's okay to drift. No one knows exactly what powers FBOTs. Some theories suggest the birth of a magnetar, a newborn neutron star spinning hundreds of times per second. Others propose that a black hole forming inside a collapsing star may release energy through jets that warm surrounding material. But none of the models capture every detail, leaving these events as soft puzzles resting gently in the night sky. You breathe softly, and the universe exhales through you. Another mystery arrives in the form of optical transients that flare too brightly and fade too quickly to match known categories. A2021LWX, sometimes called one of the most luminous events ever observed, shone for 3 years, yet showed characteristics unlike any supernova or tidal disruption event. Its brightness was consistent with a supermassive black hole interacting with dense material. But even that explanation struggles to fit every observation. You can rest now. There are also events that appear only in ultraviolet wavelengths, lingering for a few days before slipping beneath detection thresholds. Some show no host galaxy at all, suggesting either extreme distance or origins in faint dwarf galaxies we cannot yet resolve. A few are so isolated that they seem to occur in intergalactic space, far from any obvious source of fuel for such luminous behavior. It's okay to drift. Astronomers sometimes call these orphans transients with no clear parent, no stellar environment, no nearby stars, to explain their sudden appearance. Yet, even in their mystery, they feel tranquil. Nothing urgent, nothing alarming, just quiet flashes drifting across the dark, recorded by telescopes and carried into the stillness of nights like this one. You breathe softly, and the universe exhales through you. A poetic scientific truth speaks softly through these events. Some lights exist only to remind us that we do not yet see everything. This gentle uncertainty is part of the universe's charm. Astronomy grows more powerful each decade, but the cosmos remains full of subtle surprises, tiny notes in a vast symphony, heard only when we listen patiently. You can rest now. Some unexplained transients are as brief as a single second. Others last for weeks. A few, like AT-2022 CMC, show evidence of powerful jets moving at 99% the speed of light. Yet their optical signatures remain oddly simple. These contradictions create room for wonder, encouraging astronomers to explore beyond familiar models. It's okay to drift. With the rise of new observatories, particularly the Vera Rubin Observatory, expected to capture 10-20 million transients per night, the coming years may reveal thousands of new anomalies. Most will fit known categories. Some will bend the rules, and a handful will be as strange and serene as the cow-like events we see today. You breathe softly, and the universe exhales through you. Even gamma-ray detectors find mysterious signals from time to time, bursts that do not match long or short classifications, or show odd temporal structures. Sometimes the bursts repeat unexpectedly. Sometimes their positions shift subtly between detections. Each one invites quiet curiosity, encouraging us to wonder without needing immediate answers. You can rest now. These unexplained flashes remind us that the universe is not finished surprising us. Even after decades of observing, measuring, and refining models, the sky still holds moments that appear briefly and vanish forever. Moments that deepen our awareness of the cosmos, not through clarity, but through gentle ambiguity. It's okay to drift. As we move forward, we will return to calmer ground, the overarching serenity of the universe itself, a place where all these mysteries coexist peacefully. But before we shift into that final descent, rest here in the glow of these cosmic riddles. Let them drift across your imagination like soft sparks carried by billions of years of travel. You breathe softly, and the universe exhales through you. The next lights we meet won't ask you to understand them at all. They will simply accompany you towards sleep, quiet, distant, familiar. You can rest now. As the mysterious flashes fade into the quiet distance, the universe begins to stretch out around us again. Calm and full of drifting light, we leave behind the sudden pulses, the strange brightenings, the anomalies that appeared only once, and we enter a gentler, more spacious terrain in the cosmos. Here, the transients are not puzzles, but soft reminders of just how peacefully the universe can change. It's okay to drift. Across billions of light years, stars rise and fall in rhythms too slow for any single human life to witness. Galaxies merge over hundreds of millions of years, their spirals folding into one another like slow-moving tides. Nebulae bloom, fade, and bloom again as new stars ignite within them. Much of this cosmic ballet escapes the category of transient because it unfolds too gradually, yet it's still part of the same universal story: light appearing, changing, disappearing. You are safe here. When the word transient is used in astronomy, we often imagine a sudden event, but in truth, even the longest cosmic cycles are transients, slowly shifting patterns of gravity and light. A star vibrating gently from pressure waves, a galaxy cluster drifting across space at several hundred kilometers per second, a cold cloud collapsing over millions of years until it warms, glows, and becomes the quiet seed of a new star system. It's okay to drift. The universe is always in motion, but rarely in haste. Even the photons traveling at 300,000 kilometers per second move with the calm inevitability of something that has never needed to rush. It took 8 billion years for the universe to reach this moment, for galaxies to form, spiral, collide, and settle. And tonight, you are resting inside that long, slow unfolding. You are safe here. These slow transients offer a unique comfort. They remind us that change can happen quietly, gradually, almost imperceptibly. A red giant star swelling over millions of years, a nebula thinning as its gas drifts outward, a galaxy's arms tightening or loosening as dark matter influences its rotation. All of these transformations occur without urgency, without noise, without sharp edges. It's okay to drift. There is a poetic scientific truth gently floating through this section of our journey. The universe evolves not in sudden leaps, but through the patient accumulation of quiet moments. You may feel that truth settling in your breath, your inhale widening, your exhale softening. You are safe here. Slow transients also reveal something subtle yet profound. The universe keeps astonishing records. Light from distant galaxies carries the imprint of their past. Gas clouds retain the fingerprints of earlier stars. Cosmic background radiation still echoes the faint warmth of the early universe, spread thin over the entire sky. It's okay to drift. Astronomers study these faint signals, tracing tiny variations in temperature, just millionths of a degree, to learn about density fluctuations billions of years old. Even the largest structures in the cosmos, the great filaments and voids spanning hundreds of millions of light years, tell a story of slow change. Matter flowing toward dense regions, dark energy pulling space itself outward, everything moving, yet everything quiet. You are safe here. Some slow transients arise from stars entering new phases of life. A pulsating variable star expanding and contracting over periods of days. A Mira-type star brightening and dimming over hundreds of days. A Cepheid whose rhythmic glow has been stable for centuries. From Earth, these variations feel like breathing patterns, light inhaling and exhaling in a cosmic rhythm older than history. It's okay to drift. Even galaxies breathe in their own way. Star formation rates rise and fall. Gas flows in and out. Clusters drift together, then apart, moving at speeds we can measure but not see. On human time scales, a galaxy appears fixed, unmoving, but over billions of years, its arms wind and unwind like slow, luminous ribbons. You are safe here. And through all of these gentle changes, there is a constant light traveling, carrying stories. Every photon that reaches your eyes began as a distant warmth, a quiet release, a moment of transformation somewhere in the cosmic dark. Even when the event lasted only seconds, its light may travel for ages, bringing with it the memory of what once was. It's okay to drift. Soon, we will return to the sharper mysteries, the rare gamma-ray flashes that challenge our understanding, the brief transients that appear without warning. But before we go there, rest in this wide calm. Feel the slow motion of the universe around you. Nothing here demands anything of you. Nothing pulls. Nothing rushes. You are safe here. Every slow change in the universe mirrors the rhythm inside you, now gradual, soft, effortless. You breathe, and the cosmos breathes with you. When you're ready to drift forward, the next mystery will rise gently, like light returning to the horizon. It's okay to drift. As we float farther into this gentle region of cosmic time, the universe seems to loosen even more, as though countless slow-moving patterns are unfolding in silence around us. These are not the sudden transients we first explored, nor the brilliant flashes that rose and faded in moments. These are the lingering changes, soft, patient transformations that shape galaxies, stars, and entire clusters across ages we can hardly imagine. It's okay to drift. Some of the most delicate transients in the universe arise not from explosions or collisions, but from simple shifts in balance. A star cooling as its fusion rate eases, a galaxy dimming slightly as its supply of star-forming gas thins, a cloud of dust drifting into a region where starlight warms it, causing a faint infrared glow that lasts for thousands of years. These changes are almost imperceptible, yet they accumulate slowly, like ripples widening across a still pond. You are safe here. Variable stars offer some of the clearest examples of this quiet change. Delta Scuti stars pulsate with periods of just a few hours. RR Lyrae stars vary on timescales of about a day. Cepheids breathe in cycles of days to months, their brightness rising and falling with such consistency that astronomers use them as cosmic distance markers. Even these rhythmic shifts feel gentle, softening, returning. It's okay to drift. Some stars experience long-term variability that unfolds almost invisibly. Red supergiants, for instance, can dim and brighten over hundreds or thousands of days. Their immense atmospheres expanding and contracting like slow tides. These shifts are so subtle, they require patient observation over years. From Earth, they feel like the universe inhaling and exhaling on scales far larger than our own. You are safe here. Even planetary systems undergo slow transients. Dust rings form around young stars, shifting in brightness as particles collide, grow, or drift outward. Gas giants migrate gently through stellar systems, guided by gravitational nudges and resonances over millions of years. Orbits adjust, settle, and stabilize, creating the architecture that shapes future worlds. It's okay to drift. There is a poetic scientific truth that reflects this cosmic pacing. What appears still is only moving too slowly for us to see. Galaxies spin with periods of 200 to 500 million years. Nebulae drift apart across thousands of generations. And even dark matter halos evolve so gradually that their changes feel like permanent states. Yet, everything shifts. Everything breathes. You are safe here. As we look deeper into the calm structures of the universe, we encounter the quiet glow of galaxy clusters. These clusters, each containing hundreds or thousands of galaxies, drift through space in slow, gravitational dances. Hot gas between them emits a faint X-ray light, while gravitational lensing gently bends the paths of photons traveling from galaxies behind them. These distortions accumulate over billions of years, shaping the cosmic tapestry we observe today. It's okay to drift. Even the cosmic web, the vast network of filaments and voids stretching across the universe, evolves in slow, graceful movements. Matter flows toward denser regions at speeds of hundreds of kilometers per second. Yet the scale is so immense that the motion feels frozen to our eyes. Voids expand. Filaments tighten. Clusters merge in quiet inevitability. You are safe here. The light reaching us from these structures is ancient. Photons from a distant cluster may have begun their journey when life on Earth was only beginning to take shape, or even before our planet existed at all. As space expanded, that light stretched into redder wavelengths, becoming softer, calmer. By the time it arrives, it feels less like a message and more like a memory. It's okay to drift. Even cosmic background radiation, the oldest light in the universe, changes imperceptibly over time. Once glowing at thousands of degrees, it has cooled to 2.7 Kelvin. A gentle microwave whisper spread across all of space. This glow decreases by only a tiny fraction every billion years. Yet it remains the universe's most enduring transient, fading so slowly it feels eternal. You are safe here. These gradual shifts form the backdrop for every moment of cosmic history. All the fast events we explored earlier, FRBs, Kilonovae, GRBs, unfold against a canvas shaped by eons of slow motion. In their own way, these slow transients soothe the universe, giving structure to its rhythms, softness to its evolution, patience to its unfolding. It's okay to drift. And as you listen, your breath begins to sync with this cosmic pacing, slow, weightless, unhurried, like dust drifting in a beam of soft starlight. You are safe here. In a few moments, we'll return to the sharper mysteries, those bright, fleeting lights that punctuate the cosmic night with brief wonder. But before we shift direction again, let this vast calm settle around you. The universe has been drifting for billions of years, and tonight, you are drifting with it. It's okay to drift. When you're ready, we'll follow the faint glow toward the next mystery, a quiet step deeper into the unknown. As we drift out of the quiet expanse of slow cosmic change, a faint shimmer begins to rise, like the first distant lights of a shoreline emerging through mist. These are the transients that sit between the sudden and the slow events that unfold over days, weeks, or months, leaving soft trails of light that stretch gently across time. They bridge the gap between the instant and the eternal, offering a calm rhythm to the cosmic landscape. You are safe here. Some of the most intriguing transients in this middle realm are those that brighten gradually, as though the universe is taking a long, steady breath. Luminous red novae, for instance, emerge when two stars gently spiral inward until their outer layers begin to merge. The light brightens over time, often reaching a peak several thousand times brighter than the sun before slowly fading into a warm, dusky glow. It's okay to drift. These stellar mergers are not explosive in the usual sense. They are softer, shaped by the delicate exchange of material between two stars drawn together by gravity. As their atmospheres blend, a thick envelope of gas forms around them, glowing in shades of red and infrared. This glow can last for months, sometimes even years, slowly receding as the merged star stabilizes. You breathe softly, and the universe exhales through you. One of the most famous events of this type was V838 Monocerotis. It brightened dramatically in 2002, producing a breathtaking light echo that continues to expand today. The echo, traveling at the speed of light, nearly 300,000 kilometers per second, illuminates surrounding dust as it moves, creating an expanding halo that looks like ripples in a perfectly still lake. You are safe here. Light echoes are gentle messengers. They do not alter the dust they pass through. They simply reveal it for a moment. The dust, in turn, reflects the glow back toward us, delivering a delayed replay of the event without any urgency. It's a phenomenon that teaches us that light, once released, continues its journey with patient, unwavering grace. It's okay to drift. There's a poetic scientific truth in these echoes. Light remembers the paths we cannot see. Even long after the original brightening has passed, its reflection continues outward, painting soft shapes across space, reminding us that the universe carries its memories forward in every direction. You breathe softly, and the universe exhales through you. Other mid-timescale transients arise from stars that expel material into surrounding space. Some do so through slow, rhythmic pulses, releasing shells of gas that glow when heated by starlight. The result is a series of faint, expanding rings, sometimes visible for centuries. Astronomers have found such rings around aging stars more than 1,000 light-years away. Their symmetry so delicate, it feels like the cosmos practicing breathwork. You are safe here. And then, there are the stars that dim instead of brighten. Our Coronae borealis stars, for instance, can fade dramatically as carbon-rich dust momentarily forms in front of them. These stars may dim by several magnitudes in just a few days, remain faint for months, then slowly brighten again as the dust disperses. Nothing violent occurs, only the gentle formation and dissolution of drifting grains. It's okay to drift. Variable and dimming stars show that transients do not need to be bright to be meaningful. Sometimes, absence carries as much beauty as presence. The gentle dimming, the soft return of light, all of it reflects changes in the star's atmosphere. Subtle dances of chemistry and temperature that unfold quietly across years. You breathe softly, and the universe exhales through you. These slow to medium transients provide astronomers with opportunities to watch cosmic processes in real time, not in an instant, but in a span long enough to observe, long enough to understand, long enough to feel the universe moving at a pace closer to our own. You are safe here. Some events, like luminous blue variables, undergo unpredictable brightenings or eruptions. Eta Carinae, for example, experienced a great eruption in the 19th century, brightening to become one of the most radiant objects in the sky before gradually fading again. Its surrounding nebula, the homunculus, expands gently at speeds of a few hundred kilometers per second. Slow, steady, unhurried. It's okay to drift. Across all these events, a calming pattern emerges. The universe rarely changes abruptly without leaving a long, soothing trail of light behind. Even when something brightens or dims, the transition is gradual, unfolding with the patience of deep time. You breathe softly, and the universe exhales through you. As we continue, we will step into even softer territory, strange transients that flicker at the edge of detection, events whose origins remain unknown, moments when the cosmos breathes in ways we do not yet understand. But you do not need answers. You only need the gentle rhythm of drifting through these cosmic movements. You are safe here. When you're ready, we'll follow the next faint glow, soft, slow, suspended in the dark. As we drift deeper into this middle region of the cosmic night, the lights around us grow gentler, softer, and more mysterious. They no longer flare suddenly, nor do they unfold over cosmic ages. Instead, they shimmer in slow, uncertain rhythms, transients that take their time, revealing only fragments of themselves before fading into silence again. You are safe here. Among the strangest in this family are objects known as intermediate luminosity, red transients, or ILRTs. They sit between novae and supernovae, too bright to be one, too faint to be the other. ILRTs glow like warm embers, rising gently over days before releasing a slow cascade of light that may last for weeks or months. Their origins remain mysterious, though many suspect they come from stars shedding large amounts of material in quiet, drawn-out episodes. It's okay to drift. These events often show strong signatures of dust formation. As the ejected gas expands and cools, dust grains condense, absorbing light and re-emitting it in a soft infrared glow. Astronomers observing ILRTs may watch as their brightness shifts from warm red to deeper infrared tones, mirroring the cooling of the material as it drifts into space at speeds of a few hundred kilometers per second. You breathe softly, and the universe exhales through you. Another intriguing category includes the so-called gap transients, objects whose luminosity and timescales fall squarely between known types of stellar eruptions. These events resist labels, behaving differently from anything else we observe. Some brighten unusually fast, then fade into lingering plateaus. Others release bursts of energy in stages, as though the underlying physics hesitates, pauses, continues. You are safe here. A poetic scientific truth rises quietly through these enigmas. Not every light belongs to a pattern we already understand. Some lights exist simply because the universe is older, wider, and more varied than our current models can hold. It's okay to drift. In recent years, astronomers have spotted optical transients with puzzling spectral signatures, features that appear too narrow, too wide, or too asymmetric to match known stellar or explosive processes. For example, some mid-duration transients show strong calcium lines, suggesting material ejected in unusual proportions or under conditions not yet fully understood. These calcium-rich events may eject matter at thousands of kilometers per second, yet their glow feels calm from here, a soft expansion of light over several nights. You breathe softly, and the universe exhales through you. There are also transients that depend heavily on their surroundings. When material interacts with a dense circumstellar environment, the resulting glow can vary slowly, almost like a conversation between star and space. Light reflects off nearby dust clouds, creating delayed echoes and subtle brightenings that repeat over weeks. These interactions reveal the story of the star's past winds, eruptions, outflows, all written into the surrounding gas. You are safe here. Some fading transients exhibit unusual color evolution. Instead of cooling steadily, they shift between warm and cool tones unpredictably. This may hint at complex geometries, disks, streams, shells, structures that scatter light in ways that change as they expand. Each variation is a message carried across millions of years, delivered now with gentle precision. It's okay to drift, and then, drifting even deeper into strangeness, we reach events that flicker near detection, limits, soft optical flashes, faint radio whispers, brief dips in stellar brightness that appear only once. These are not dramatic enough to become headlines, yet they are precious to astronomers who search for the quietest signs of cosmic change. Some of these faint events may signal the collapse of small stars, others the slow cooling of white dwarfs, others still processes we have yet to imagine. You breathe softly, and the universe exhales through you. There are transients that do not correspond to any physical model at all. They appear only in one wavelength, or only in one filter, never repeating, never revealing their true origin. Perhaps they are the remnants of rare stellar interactions, or glimpses of unusual compact objects, or even observational artifacts filtered through cosmic dust in unpredictable ways. Whatever they are, they pass gently through our sky, inviting curiosity rather than urgency. You are safe here. Through all these mysteries, one idea comforts: the universe does not need to be fully understood to be deeply soothing. Some lights drift across the sky for reasons known only to themselves, appearing long after their source has dimmed, reaching us after traveling for millions or billions of years. It's okay to drift. As this chapter of mid-time-scale transients settles into the quiet of space, we begin to approach the final arc of our journey, where the rarest, most elusive cosmic flashes shimmer at the threshold of perception, guiding us slowly toward rest. But we'll meet them softly, without rush. You breathe gently, and the universe exhales through you. When you're ready, we'll step into the faintest region of the cosmic map, a place where even mysteries fall asleep. You are safe here. As we drift onward, the universe begins to dim around the edges, as though the stars themselves are lowering their voices. We have moved past the bright transients, past the mid-timescale glows, past the soft expansions of merging stars. Now, the cosmos offers us its quietest lights, faint signals that barely rise above the darkness. Lights so soft they seem almost unsure whether they want to be seen at all. You are safe here. Some of these gentle events appear only in the lowest frequencies of radio waves. They drift upward as thin murmurs, lasting just long enough for our instruments to notice. From Earth, they feel less like flashes and more like ripples on an invisible ocean, delicate, passing, persistent only for moments. Astronomers sometimes call them micro-transients because their energy is so small that even a nearby galaxy could hide them completely. It's okay to drift. One class of these soft signals is known as long-duration radio transients. Unlike fast radio bursts, which appear and vanish in milliseconds, these linger for hours or even days, glowing gently before fading into background noise. Their origins remain unknown. Some may arise from slowly cooling remnants of stellar explosions. Others could come from compact objects interacting with surrounding material in subtle, intermittent ways. You breathe softly, and the universe exhales through you. Some long-duration radio signals appear only once in the entire history of observations. A single pulse, then silence. Researchers track them carefully, comparing signals across arrays. Yet, often, no source is ever found, no star brightening, no galaxy active. Nothing except a faint memory on a detector. You are safe here. There are also optical transients so faint that they can only be detected when telescopes stare at the same patch of sky for hours. Some of them brighten by a few hundredths of a magnitude, just enough to suggest a gentle shift deep within a star's outer layers, but not enough to give away the full story. These events feel like the universe breathing in soft increments, too subtle for the naked eye to detect. It's okay to drift. A poetic scientific truth drifts through these faint signals. Some stories are written in ink, too soft for us to read. Yet we feel them just the same. These quiet transients remind us that the cosmos does not reveal everything through brilliance. Sometimes its calmest changes whisper the loudest truths. You breathe softly, and the universe exhales through you. In recent years, astronomers have detected a new category of faint, blue transients that brighten only slightly before fading below detection thresholds. They may last just a few hours, and their spectra show minimal structure, no strong lines, no dramatic shifts, only a smooth glow that feels like the soft edge of a much larger event. Perhaps they belong to a new class of stellar variability. Perhaps they are echoes of faint eruptions on distant stars. Or perhaps they are simply cosmic breaths we have only just learned to notice. You are safe here. Other faint transients appear as short-lived dips in brightness, a star that slightly dims, then returns to its normal state minutes or hours later. Many theories attempt to explain them: cool spots rotating across the stellar surface, dust clouds passing in front of the star, or tiny clumps of material drifting through its outer atmosphere. Whatever the cause, the effect remains gentle. A soft, dimming, a soft return. It's okay to drift. One of the rarest categories is the ultra-slow transient. These do not brighten suddenly or fade sharply. They shift over months or years, often too subtle for a single observation to capture. Only by comparing images taken decades apart do astronomers realize something has changed. A star now slightly brighter, or a nebula glowing in a new shade, or a region of the sky where a faint object has quietly disappeared. You breathe softly, and the universe exhales through you. Even more mysterious are the transients that appear simultaneously in multiple wavelengths without any clear pattern. A faint radio rise paired with a subtle ultraviolet dip, a soft infrared pulse following a tiny optical brightening. These multi-wavelength murmurs hint at processes too delicate for our instruments to isolate. They are glimpses into the fine-grained texture of cosmic evolution. Tiny adjustments the universe makes as it moves forward unhurriedly. You are safe here. As these faint signatures surround us, you may feel a similar softening within yourself, as though your thoughts are dimming gently, your breath lengthening, your awareness settling like dust in a golden beam of light. Nothing here asks anything of you. Nothing pulls or presses. Everything simply unfolds in its own time, and you drift with it effortlessly. It's okay to drift. Soon, the path will lead us into the final collection of cosmic mysteries, the quiet transients that act like the universe's closing notes, gentle reminders that even endings can feel like beginnings when viewed from far enough away. But for now, stay in this faint glow. Let the smallest lights hold you. Let the quietness settle across your body like a soft blanket of starlight. You breathe softly, and the universe exhales through you. When you're ready, the final whispers of the cosmos will rise to meet you, guiding you deeper into rest. As we move deeper into this faint, shimmering territory of the cosmos, the lights around us seem to thin into a soft haze. It's as though the universe has lowered its brightness, settling into a quieter tone, preparing you for the final stretch of this long, drifting journey. You are safe here. Many of the transients in this region are so subtle that they almost escape notice entirely. Some brighten or fade over periods of hours. Others shift only slightly over years. Their signatures are gentle, their presence barely more than a whisper against the dark. It's okay to drift. Astronomers often find these faint events only after deep analysis, comparing old sky surveys with new ones, looking for soft discrepancies, tiny variations a casual glance would never detect. Sometimes, a star appears just slightly dimmer than before, or a region glows a little more warmly than earlier images suggest. These are not dramatic changes. They are the slow, patient notes of a cosmic lullaby. You breathe softly, and the universe exhales through you. Some of these changes come from stars moving through dusty regions of their galaxies. Dust absorbs starlight and re-emits it at longer wavelengths, creating subtle shimmering arcs that shift over years. From afar, these arcs look like veils drifting across a lantern flame, thin, delicate, always moving. You are safe here. Then there are the softest radio signals, so faint they blend into the background until careful filtering reveals their presence. These signals may persist for days or weeks. Their strength rising and falling in patterns without clear explanation. Researchers have proposed everything from slowly cooling neutron star remnants to gentle shocks from ancient stellar eruptions. Whatever the cause, the effect is calming a mere hint of motion in the deep quiet of space. It's okay to drift. A poetic scientific truth rests in these quiet signals. Even the faintest light carries the memory of its journey. Every photon, no matter how soft, traveled across millions or billions of kilometers to arrive in this moment. It brings with it no urgency, only presence. You breathe softly, and the universe exhales through you. In some galaxies, faint optical transients appear in regions far from star-forming activity. A sudden glow in a lonely corner of a galactic halo. A brief shimmer from a remote dwarf galaxy. Such events defy easy interpretation. They might be distant stellar eruptions filtered by heavy dust, or subtle interactions between compact objects, or something entirely new. But from here, they feel peaceful, just small flickers in an endless ocean of dark. You are safe here. Some of the faintest transients occur in the outskirts of galaxy clusters. Here, thin filaments of gas interact with drifting stars, creating soft, low-energy emissions, detectable only through careful measurement. These faint glows tell the stories of gravitational tides that have been unfolding for hundreds of millions of years. You sense their patience, their stillness, the way their light takes its time. It's okay to drift. From time to time, astronomers observe objects that brighten slightly across multiple wavelengths at once. A small optical rise, a soft infrared pulse, a faint radio hum. These multiband murmurs may represent slow accretion processes around white dwarfs, or minor instabilities in aging stars, or distant echoes from interactions we have yet to imagine. Whatever their origin, the signals arrive gently, asking nothing of you. You breathe softly, and the universe exhales through you. The faintest transients of all might be the ones that leave traces not in brightness, but in absence, a star that quietly disappears behind a drifting dust cloud, a background galaxy momentarily dimmed by a passing clump of cold gas, a region of the sky whose glow softens ever so slightly, as though exhaling. These subtle dimmings reveal the fine structure of cosmic dust grains smaller than smoke, drifting in coils around stellar winds. You are safe here. Sometimes, astronomers discover slow changes only by accident, a nebula glowing more intensely than in decades-old photographs. A white dwarf pulsing with slightly altered timing. A faint source showing a barely perceptible color shift. These tiny signatures, almost invisible, remind us how much the universe is always doing. Even in its quietest corners, it's okay to drift. As these soft transients gather around you, you may notice your own breath deepening, your body loosening, your mind beginning to float closer to the quiet threshold of sleep. The universe slows with you. The darkness widens with you. You breathe softly, and the universe exhales through you. We are nearing the final lights of our journey, the last handful of cosmic whispers, drawn from the edge of what we can observe, carrying us gently into the deepest part of the night. But there is no hurry. The cosmos has drifted for billions of years to bring you here, to this soft, resting place. You are safe here. When you feel ready, we will follow the final, faint echoes, slipping deeper into calm, toward the quietest mysteries of all. As you drift farther into the quiet of the universe, the glow around you begins to thin into something softer, almost weightless. We have passed through the bright flashes, the long fades, the gentle dimmings. Now, the cosmos reveals only its faintest riddles, the final, subtle whispers that lie between detection and silence. You are safe here. These are the transients that challenge even the most patient observers, events that last just long enough to be noticed, but too briefly to be understood. A rise in gamma rays, followed by nothing, a faint pulse of X-rays, with no corresponding optical glow, a short-lived shimmer in the ultraviolet, barely distinguishable from noise. It's okay to drift. Some of the most enigmatic of these are known as orphan afterglows. In theory, they come from gamma-ray bursts whose initial jets are not pointed toward Earth, so we never see the burst itself. Only the soft afterglow that follows. These afterglows brighten slowly, then fade over days or weeks, appearing in isolation from any visible event. For astronomers, they are puzzles. For you, they are just gentle flickers in a quiet sky. You breathe softly, and the universe exhales through you. There are also X-ray flashes, transients, that share some properties with FRBs, but release most of their energy in lower energy X-rays. They last longer than typical bursts, sometimes up to 1.000 seconds. Yet they glow with a softness that makes them feel more like distant lanterns than cosmic engines. Their origins remain debated. Off-axis jets, unusual stellar collapses, or something else entirely. You are safe here. A poetic scientific truth settles faintly here. Even the universe's questions arrive as light. You don't need to answer them. You only need to drift beside them, letting their glow soften around you. It's okay to drift. Some transients appear exclusively in soft X-ray or extreme ultraviolet ranges, bands of light invisible to human eyes, visible only to instruments above Earth's atmosphere. They brighten for a few minutes, fade for a few hours, then vanish. No visible star, no obvious remnant, only a momentary shift in a wavelength we rarely consider. You breathe softly, and the universe exhales through you. More mysterious still are the events discovered accidentally, soft glimmers found only because telescopes happen to be looking in the right direction at the right time. A faint ultraviolet pulse, a slight rise in blue light, a disappearing radio whisper. They leave behind no clear clue, no pattern, no second chance to capture them. But even their fleeting presence adds calm texture to this night. You are safe here. Astronomers sometimes refer to the faintest category as single epoch anomalies. These are events observed only once, in a single exposure, without any return appearance. They may represent the shortest-lived phenomena ever seen, moments that lasted less than a minute, or even less than a second. Moments that carried their entire existence in just a handful of photons. It's okay to drift. When comparing sky surveys decades apart, scientists sometimes discover that a faint source has appeared where none existed before, or disappeared without leaving any trace. These vanishing or emerging objects may be faded remnants of old explosions, long cooling neutron stars, or the quiet flicker of a distant black hole nibbling at the edges of a passing gas cloud. You breathe softly, and the universe exhales through you. Some transients shift unpredictably across wavelengths. A small radio pulse appears, followed hours later by a faint optical brightening, then days later by a soft infrared glow, each stage too weak to reveal a clear cause. Yet, together, forming a delicate pattern, like listening to the universe hum a song in notes too subtle to hear fully. You are safe here. Still others are hidden in gravitational lensing events. A distant star brightens ever so slightly as a foreground object passes directly between it and us, bending its light with gentle gravitational pull. This brightening can last days, weeks, or months, slow and smooth. A cosmic caress from an invisible object passing quietly in the dark. It's okay to drift. Even the expansion of space creates transients light stretched, cooled, softened as it travels across billions of years. Photons that began their journey as intense bursts may arrive now as gentle microwaves, no more threatening than the warmth left behind after a candle is blown out. You breathe softly, and the universe exhales through you. And through all of these faint mysteries, a single feeling settles in the universe is not trying to be understood tonight. It is simply unfolding, softly, slowly, allowing you to rest inside its stillness. You are safe here. Soon, we will follow the final lights of this journey, the softest signals, the quietest memories of ancient events, a closing melody before you drift fully into sleep. But for now, stay with this gentle darkness, these tiny, unhurried questions that ask nothing of you. It's okay to drift. As you drift deeper into the quiet of this cosmic night, the universe seems to fold itself around you, not closing in, but softening like a great expanse, lowering its voice until it becomes a whisper only the calmest part of you can hear. You are safe here. These final transients shimmer at the threshold between presence and absence. They don't announce themselves. They don't insist. They appear gently, as though the cosmos is exhaling small secrets into the dark. It's okay to drift. Some of the faintest cosmic signals come from cooling neutron stars, tiny, dense remnants left behind after ancient explosions. As they age, their glow diminishes, slipping from X-rays into ultraviolet, from ultraviolet into optical, until only the faintest warmth remains. Their cooling curves stretch across millions of years. A gentle, downward slope that feels almost like a lullaby written in fading light. You breathe softly, and the universe exhales through you. Other soft transients emerge from the slow accretion of material onto white dwarfs. A small stream of gas drifts in, heats, glows, and fades again. These flickers can last anywhere from minutes to days. But from here, they feel like ripples barely touching the surface of awareness. You are safe here. There are also ancient remnant supernova shells so expanded and diffuse that they barely emit anything at all. Their edges glow faintly in infrared, revealing arcs that have been drifting outward for tens of thousands of years. These ghostly shapes are transients too, though their changes are so slow that only long, patient observations reveal their movement. It's okay to drift. A poetic scientific truth settles gently here. Even what fades still carries the memory of light. These remnants, these glows, these soft arcs in the dark, they all come from something that once shone brightly. Now they exist only as whispers, and their quietness is a comfort. You breathe softly, and the universe exhales through you. Some transients occur not because a star brightens, but because something passes between you and the star, a drifting cloud of dust, a small, cold planetesimal, an unseen object far from its parent star. These events can dim the star by only a fraction of a percent, a soft shadow passing across a beam of ancient light. Even these shadows feel gentle, as though the universe is adjusting its brightness just slightly, so you can rest more easily. You are safe here. Sometimes the faintest transients are found only after years of data are combined, tiny variations becoming clear when the noise is smoothed away. A soft brightening, a slow fade, a color shift that seems to come from nowhere. These are cosmic subtleties, almost secrets, shared only with those who look long enough, quietly enough. It's okay to drift. There are events so faint they exist only as gravitational effects, a small lensing of background light, a barely perceptible distortion of a star's position. These transients leave no glow at all, only the slightest bending of space itself. From Earth, they appear as gentle irregularities, moments when the universe rearranges its patterns in the softest possible way. You breathe softly, and the universe exhales through you. Some rare transients may be tied to objects we don't yet fully recognize: ultra-cool brown dwarfs, drifting fragments of failed stars, cold gas clouds illuminated briefly as they pass through starlight. Each one is a quiet visitor. Each one appears without rush, without urgency, simply drifting through the vastness the same way you drift through this moment. You are safe here. As you move deeper into this stillness, you may feel the edges of your awareness loosening, thoughts slowing, breath deepening, the body settling into a weightless rhythm. This is the universe guiding you gently, the same way it guides the faintest photons across billions of kilometers. It's okay to drift. Soon, you'll reach the final region of this journey, a place where the softest echoes gather, where light becomes memory, and memory becomes rest. In that place, you will feel held, carried, and gently lowered toward sleep. You breathe softly, and the universe exhales through you. But there is no need to hurry. The universe does not hurry, and neither do you. Stay with this quiet glow a little longer, floating in the soft darkness between one breath and the next. You are safe here. When you're ready, the final descent awaits, a slow fall into cosmic stillness, guided by the faintest lights of all. As you drift into the final stretch of this journey, the universe grows quieter than ever, a deep, velvety stillness spreading across the dark like a gentle tide. You are safe here. The last transients we meet tonight are not bright, not sudden, not even fully visible. They live at the edge of perception, soft echoes of events that happened long ago. their light stretched thin by distance and time until it becomes more feeling than sight. It's okay to drift. Some of these final whispers are ancient afterglows, remnants of events that ended millions or billions of years ago. Their photons have traveled across expanding space, cooling slowly, fading gently, until only the faintest vibration remains. When they finally reach you, they feel less like signals and more like memories, carried on a quiet breeze. You breathe softly, and the universe exhales through you. There are transients so faint that only the largest telescopes can sense them, a subtle brightening in infrared, a tiny shift in ultraviolet, a low hum in radio waves. They do not ask for understanding. They simply appear, inhale a little light into the sky, and disappear again. You are safe here. Some come from cooling white dwarfs, old stars settling into their final stages, shedding their warmth slowly, a gentle decline in brightness, spread across thousands of years, barely measurable from one decade to the next. The universe knows how to dim itself softly. It's okay to drift. A poetic scientific truth settles like dust on still water. The faintest light can travel the farthest distances. These photons, soft as breath, have crossed intergalactic space to find you here. In this quiet moment, you breathe softly, and the universe exhales through you. Some transients arise from old supernova remnants, vast, diffuse clouds of gas drifting outward, their edges glowing faintly as they collide with the thin interstellar medium. These changes are so slow that they are almost invisible, yet they continue, year after year, like a lullaby written in expanding circles. You are safe here. Others come from distant black holes, not through bright flares, but through the soft modulation of radio waves as drifting material moves around them. The signal rises slightly, fades slightly, breathes in delicate pulses that blend seamlessly into the background. It's okay to drift. There are even transients that come from the shifting alignment of stars and galaxies, gravitational microlensing events that brighten a distant star by just a touch, for just a moment. When an unseen object passes across our line of sight, these brightenings unfold slowly, over days or weeks. Soft arcs of light shaped not by fire, but by gravity's gentle touch. You breathe softly, and the universe exhales through you. Some of the faintest signals of all are simply fluctuations in the cosmic background, the residual glow of the early universe. Cool and even, spreading across the sky at 2.7 Kelvin. Tiny variations in this ancient light reveal the earliest patterns of matter, the first quiet ripples that would one day become galaxies. These fluctuations are transients to the universe's oldest, slowest lullabies. You are safe here, and as these faint echoes drift through you, your own breath begins to match their rhythm. Slow, long, unhurried, thoughts soften, edges dissolve, and the quiet around you deepens into something wide and weightless. It's okay to drift. The universe does not hurry toward its mysteries, and neither do you. You float here, held by the same calm gravity that guides the softest lights across billions of years. You breathe softly, and the universe exhales through you. Soon, we will move into the final descent, the place where echoes fall silent, where the cosmic night settles completely, where your thoughts loosen their last threads and drift into sleep. But for now, rest in this quiet glow. You are safe here. When you're ready, the final whisper waits in the dark, guiding you gently toward the softest part of the night. As you drift into the quietest corner of the universe, everything grows softer, lighter, as though even the stars have begun to sleep. You are safe here. These final transients exist almost beyond perception, small tremors of light, distant murmurs of energy, barely more than a suggestion in the dark. It's okay to drift. Some of them are echoes of echoes, light that has been scattered across dust clouds, reflected, redirected, stretched thin until only the gentlest shimmer remains. These echoes remind you of the line whispered earlier. Light remembers the paths we cannot see. You breathe softly, and the universe exhales through you. Other signals come from drifting particles of dust, warmed by the faint glow of forgotten stars. They release soft infrared light, a glow so low, so tender, that only the quietest instruments can hear it. You are safe here. Some of the last transients the universe offers you come from distant regions where stars no longer form, where galaxies have grown old and dim. Here, light behaves like a long, slow sigh, emerging in gentle pulses as cold gas clouds rearrange themselves. It's okay to drift. A soft truth rises. Familiar. Now, even what fades still carries the memory of light. You heard it before, and here it returns. A quiet thread looping back through your breath, drawing you deeper into rest. You breathe softly, and the universe exhales through you. Sometimes, the faintest cosmic changes are simply fluctuations in ancient radiation, tiny tremors in the afterglow of the Big Bang. They drift across the sky as background warmth, a gentle field of memory spread thin across the whole of existence. You are safe here. Other times, a transient is nothing more than a small shift in starlight caused by an object passing quietly between you and the star. A dimming not meant to signal anything urgent, only a passing shadow in a universe full of drifting shapes. It's okay to drift. In the stillness, you begin to feel the rhythm of the cosmos echoing inside you. Slow, steady, open. The same rhythm that guided bright supernovae and faint radio murmurs and ancient photons on their billion-year journeys. You breathe softly, and the universe exhales through you. A line from earlier returns, drifting up like a memory surfacing from deep water. The faintest light can travel the farthest distances. And tonight, that faintest light has reached you. You are safe here. Some transients now become more emotional than physical, not bursts of energy, but the soft awareness that even the universe rests. Stars cool, galaxies settle, nebulae thin into quiet strands of dust. Everything finds stillness eventually. It's okay to drift. Even time seems to loosen here, stretching just enough for you to float within it without weight, without effort, without thought. You breathe softly, and the universe exhales through you. And slowly, with each breath, you begin to reach a place where the cosmos feels like a blanket wide, warm, and endlessly gentle. The mysteries of earlier sections The bright bursts, the fast whispers, the long fades all dissolve into a single, soft-feeling rest. You are safe here. A final memory circles back. Soft as silk, some stories are written in ink too soft for us to read. Yet we feel them just the same. This, too, is part of your night, part of your drift, part of the quiet unfolding that holds you now. It's okay to drift. You feel your breath growing slower, your thoughts loosening, your body becoming lighter, as though the darkness beneath you is lifting you gently, guiding you toward the last moments of wakefulness. You breathe softly, and the universe exhales through you. And now, at the edge of sleep, the universe dims to a soft, silent glow, a gentle field of memory and quiet motion carrying you forward, carrying you inward, carrying you home. You are safe here. Night grows softer now, as though the entire universe has lowered itself beside you. Your breath slows, your thoughts drift, your body loosens into the dark, and in this final quiet, light still travels. Light still moves through the deep. Light still carries every gentle memory that guided you here. Light still travels. The darkness around you is not empty. It holds you, the way the sky holds every drifting star, without pressure, without expectation, without end. And as your breath settles into the softest rhythm, the universe breathes with you, a slow, echoing tide moving through the dark and through the calm that is rising inside you now. The universe breathes through you. All the mysteries you've met tonight, the bright, the faint, the fleeting, fall into a gentle hush. They rest. And so do you. Nothing pulls. Nothing asks. Nothing remains except this quiet path leading inward, leading downward, leading home. And in this last moment before sleep opens, you feel the simple truth settle like starlight across your chest. You are home. You can rest now. The night widens. The breath softens. The universe holds you, slow and low. As you drift into sleep, 12 seconds of quiet. If you're still awake, the next wonder waits in the light ahead.